So in this video, we're going to look at building quadratic functions, and in building quadratic functions, what we're going to be doing is we're going to be writing the equation of the quadratic function given characteristics about that function. So let's look at the first problem. So our directions for all the three problems we do are going to be our directions are going to be write a quadratic function. Well, let's write, not write. A quadratic. Write the equation of a quadratic function that, okay, number one, has x-intercepts that are given and passes through 1, 4. Okay, so notice we have x-intercepts given to us, so something should jump out about the form you should probably be using. So the forms that we have are intercept form, we've got vertex form, we've got standard form. If you are given the intercepts, why not start in intercept form? Maybe it's going to lead you to a quadratic function. Now, if you have a quadratic function, you've got a value for a, p, and q. Okay? So right now, here's one of the x-intercepts. Oops, I didn't mean to put 0, -5. I apologize. That should have said -5, 0. They're both x-intercepts. Not one's an x-intercept, one's a y-intercept. And there's another x-intercept. So p is 2 and q is -5. So that's y equals a times x minus 2 times x minus -5. So we could clean that up a little bit. A times x minus 2 times x plus 5. But there are an infinite number of quadratics that have the exact same x-intercepts. Okay, but their dilations are all different. So you need to make sure you're writing the specific quadratic function for the quadratic that not only has these two as x-intercepts, but passes through 1, 4. There's only one a value, there's one unique a value that's going to put you through 1, 4. And we have to name it, because this is not intercept form. You have to give the exact value here. So what do? You plug in 1, 4 for x, y, so that you find the right a value, because remember, all of the points that fall on a function make the equation true. So we plug in 4 for y and 1 for x. And we get 4 equals a times -1 times 6. So that's going to be 4 equals, multiply that, that's -6a. Divide by -6, and a equals -4, 6, which we could simplify to -2/3. So this quadratic function has a equation of y equals -2/3 times x minus 2 times x plus 5. Now, that's the quickest form to start in x-intercepts, okay? When you have a quadratic, you need 3 points, unless you have a specific point. Otherwise, you need 3 points. If you specifically have the x-intercepts and then another random point, I would use the intercept form to write your function. Now, if you needed to meet these requirements and be in standard form, okay, I would write it in intercept form first and then convert it to standard form. Okay, so that's problem number 1. Here's problem number 2. So we're going to write the equation of a quadratic function that has a vertex of 2, -3 and passes through the point 7, -18. Now, there are an infinite number of quadratic functions that have this same vertex, but there's only one unique quadratic function that has this vertex and passes through this point. So, since I have the vertex, what's standing out in my head right now is vertex form might be the way we need to write this or build this quadratic function. Now, if you notice, the 3 unknowns that we need values for are a, h, and k. Okay? And even though you only have 2 pieces of data here, this vertex, when you're in vertex form, this holds 2 of the 3. H comma K is the vertex. So you know what H is. H is 2 and K is -3. So we could fill that in. This is y equals A times x minus 2 squared plus -3 or just -3. So if you have the vertex and another point, you technically have just 2 pieces of data there. That is the minimum, okay? It's either vertex and a point, or you need 3 random points to do a quadratic. But the reason that we have enough, even though we only have 2 pieces of information, the vertex is so important, okay? It holds for us this HK, it holds for us 2 of the 3 unknowns. So now there are an infinite number of quadratics that have this vertex, but only one passes through 7, -18. So we have to plug in this point so that we find the A value that will put us on the path to pass through this point. So that's going to be -18 equals A times 7 minus 2 squared minus 3. And we have to solve for A. So we have to make sure we're getting A by itself. So we have to do some order of operations here. 7 minus 2 is 5. 5 squared, 25. So this is -18. A times 25 minus 3. So this is -18 equals A times 25 is 25A minus 3. Now we can start isolating A. So we add 3 to both sides. That gives us -15 equals 25A. Divide by 25. And that gives us A equals -15 over 25, which is -3/5. So this would be y equals -3/5 times x minus 2 squared minus 3. And so we just built the quadratic function that satisfies these conditions. And we were able to use vertex form here because we were given the vertex and 1 more point. That wasn't the vertex. So that's problem number 2, 1 more problem. Number 3, what we're told is we pass through 5, 6, 2, -3, and 4, 1. So this is the most basic necessary information to build a quadratic function. When you have no special points given to you, you need 3 points to build a quadratic function. So intercept form isn't going to help us at all. Vertex form isn't going to help us at all. But standard form is going to be the key here. Now in standard form, you need to identify what A is, what B is, and what C is. This kind of reminds me of 3 variable systems here. I have 3 unknowns, okay? And I can actually make 3 equations based on my 3 points that I have. So for point number 1, x is 5 and y is 6. If I plug that point in, I'm going to be left with an equation in terms of A, B, and C. Then if I plug this point in, I'm going to be left with an equation in terms of A, B, and C. Then if I plug this point in, I'm going to be left with a 3rd equation in terms of A, B, and C, and that's my 3 variable system there. So I plug in, I get 6 equals A times 5 squared plus B times 5 plus C. That's going to give me 6 equals 25A plus 5B plus C. Okay. Then I plug in my 2nd coordinate point, and I build a new equation. So that's going to be -3 equals A times 2 squared plus B times 2 plus C. That's going to be -3 equals 4A plus 2B plus C. Okay, and our 3rd is x is 4, y is 1. So that's going to be 1 equals A times 4 squared plus B times 4 plus C. It's going to be 1 equals 16A plus 4B plus C. And so now I have a 3 variable system of equations in which I can now solve for A, B, and C. And so now I'll have a quadratic function in the standard form. So I'll just rewrite this system. So this is 25A plus 5B plus C equals 6. This is 4A plus 2B plus C equals -3. And 16A plus 4B plus C equals 1. And I'm going to erase this over here so I have enough room. And I'm going to eliminate C first. And I'll pair 1 and 2. and then I'll pair 2 and 3. Okay. So rewrite it, 25a plus 5b plus c equals 6, 4a plus 2b plus c equals negative 3. I'll multiply the first equation by negative 1. That's going to be negative 25a minus 5b minus c equals negative 6. Add these equations up. That's going to give us negative 21a minus 3b equals, these cancel, negative 9. Equation 2 is 4a plus 2b plus c equals negative 3. 16a plus 4b plus c equals 1. I'll multiply the first equation by negative 1. That's going to give me negative 4a minus 2b minus c equals 3. Add these up. 16a minus 4a, that's 12a. 4b minus 2b, that's plus 2b. C's cancel, equals 4. So here's my two-variable, two-equation system. So I have negative 21a minus 3b equals negative 9. 12a plus 2b equals 4. So I'll try and solve for b first. I'll do that by multiplying this equation by 2 and the second equation here by 3. So that's going to give me negative 42a minus 6b equals negative 18. It's going to give me 36a plus 6b equals 12. And now what we have to do is negative 42 plus 36. That gives me negative 6. B's cancel, equals negative 6. Divide by negative 6, and I get a equals positive 1. So now I can solve for b. Okay, so b, 12a plus 2b equals 4. So 12 times 1 plus 2b equals 4. So that's 12 plus 2b equals 4. Take away 12 on both sides, so 2b equals negative 8. Divide by 2 and you get b equals negative 4. And then you pick one of the 3 original equations. So I'll pick 25a plus 5b plus c equals 6. And now plug in a is negative 1. And what did we say? B is negative 4. And now we have to find what c is. So negative 25. Okay. Oh, I'm sorry, not negative 1, positive 1, right? We said a was positive 1. So 25 minus 20 plus c equals 6. So 5 plus c equals 6. Subtract 5. And c equals 1. So a is 1, b is negative 4, and c is 1. So our quadratic function in standard form is y equals negative 1x squared minus 4x plus 1. That comes from y equals ax squared plus bx plus c, and we just said that a was negative 1, a was 1. I don't know why I keep saying that. A is 1, b is negative 4, and c is 1. X squared minus 4x plus 1.